So let's get started at the moment. Thanks for joining the webinar. It's about the leaderboard rankings for the current asset allocation Alphien. As usual, I have a bit of a forwards for you. Please mute your mics while you're not speaking. There is a text panel on the left of your screen where you can type in questions, and there will be one member of our team that will relay the question to me whilst I'm presenting, and we'll try to make it interactive and answer all the questions as we go along. So please do not hesitate to type in your questions. If you really want to speak, do not hesitate to interrupt me. You unmute your mic when you want, and you can ask the question. So yes, we wanted to have this webinar to explain to you why there are new rankings on the leaderboard now, and why we have decided to put them on. And the reason is that we want to help you participants to understand how you can make the most of your strategies and have a higher chance to win the competition. So basically, we want to help you assess whether you have fulfilled all the requirements for this competition. And just as a reminder, the requirements that are asked by our sponsor for this competition. Our sponsor is Decali Asset Management, and they are looking for an asset allocation model. And the allocation should be split between three underlyings: the US Treasury futures, a US high yield ETF, and a bank, European bank stock ETF. So the second requirement is that the model should be replicable. What do we mean by that? It means that the strategy will be implemented in the future in live markets. So it's very important that it is robust and that it keeps on trading or raising signals in the future when new data come in. And lastly, the sponsor wants to have rebalancing of like monthly frequency or twice a month, in order to keep it manageable to trade. So that's really the premises we're starting on, and we want to build on that. So we decided to try and give you as much feedback as we can in order for you to maximize these three requirements, and that's why we came up with the new rankings. So let's dig in directly. The first one is the most intuitive one, and the one that you know already because it's performance-based. I'm not going to spend too much time on that because there is nothing really new on that. Just quickly, as a reminder, the ranking at the moment is based on the Sharpe ratio. Why do we base it on the Sharpe ratio? Because indeed returns are important. So obviously the sponsor will look at the returns of the strategy, and there is going to be a hurdle. If your return is really, really low, it's probably not going to be interesting for the sponsor. However, there is also a requirement of stability, and that's why the return adjusted for your volatility and the volatility of your returns on the strategy is also important. We want something stable. We want to be able to assess whether the extra vol you are taking in your strategy is actually getting rewarded by extra return. So that's why we look at Sharpe ratio in priority. So this is quite intuitive, and it's been the case since the beginning of the competition. So let's move forward. Keep in mind that the sponsor, as I said, is also interested in the return. It's not only the Sharpe ratio, it's also the return. So there's probably going to be a hurdle for them to be interested. So keep in mind you have to maximize both the Sharpe ratio and also the returns. But what's new about the ranking system is diversification. So that's the first one we've had it. And why did we do that? Really, it's about making sure the first requirement that we talked about, that the competition is about asset allocation, is respected. What do we mean by asset allocation? It means that your model, originally the sponsor wants a model that can choose and pick where to put the maximum exposure, let's say, to an asset class depending on market regimes. That's why they've put together the three assets we are discussing in this competition, and they think that their behavior is quite different in different market regimes, and that there is a way to put up a model to switch or to allocate to an asset versus another, depending on the market regime. So it's really about making the most of these three assets during the competition. So that's why we have introduced this diversification ranking. We want to be sure that there is some sort of diversification through time. What I mean by that is that you can hold a single asset at some point in your strategy, but you have to hold overall in time a substantial amount of each asset. And if we take the drawbacks that some strategies have, we can highlight a few ones. That's the typical issues that we could think of, is that some strategies could be holding only one single asset. It might look appealing on paper to do this. However, this is no longer an asset allocation model because it's only allocated to one asset. So it's defeating the purpose of what the objective of the competition is. Secondly, you can hold few assets, all assets, sorry, for a short period of time and then switch to only one asset. Here again, this is not really making the most of the fact that we have three assets to invest, and we want to really be able to maximize the exposure to the asset that is outperforming the others. And lastly, sometimes there are long periods without any market exposure. So again, you're not allocating, you are disallocating in a way. It doesn't mean you cannot have zeros. It doesn't mean that you cannot be flat from all assets during the competition. If one of typical behaviors during crisis is that correlations of all asset classes go to 1, and then at the time you might think, I'm better off being in cash. That's fair enough. However, it needs to be only timed for these particular crisis times, but most of the time you should allocate to assets. We are in Alphien studio, and let's start with the diversification illustration. So here what I've done is I've come up with basically a very simple static payout. So what I call static is just that we're going to assign a set of weights to each underlyings, and then we're going to keep them constant in time. So very quickly, you should be now all familiar with how you build a payout for a portfolio. It's taking asset returns, as we know, as input, and here I have another parameters called weight, which are going to be static, as we will see in a minute. Obviously, if you're still unsure about this, you can go on the QLib and check the documentation of the payout function, and it's going to tell you that the first argument it needs to take is asset returns. So what do? I just take the dates of the returns, just take the number of dates, and then I create a static set of weights. So I just repeat all these weights throughout the dates of the asset returns, and then I switch to a monthly allocation, and then I return that. So what does it do? Let's just run that. Hope. And to check if the payout has the behavior we're expecting, I'm using getStrategyReturn. GetStrategyReturn is just returning the series of underlying returns, daily underlying returns for whatever we pass on. And here we pass in the 3 building blocks for the competition. Here we go. The returns are here. What does it look like? It's here down there. So we can see that every month I keep the same static weights for each underlying building block. So this is the behavior we wanted. And now we can go as usual and create our portfolio with this static payout. Here, run that. So as you see here, I am assigning 0 weight to the first building block, all the weights to the second building block, and 0 weight to the third building block. I can run now. So this is what we do behind the scenes, how we compute the diversification score. I'm just going to run this, and down here in my console, I will be able to see the results. and here it's telling me my diversification score is minus 1.66. So given what I have given you as input, you can understand or guess that the diversification score is not very good. The diversification score is scaled up to 5, 5 being the maximum diversification that you can reach with your payout. So here we have minus 1.66, so we have an intuition that it's not that good, but let's compare to something slightly more balanced. Let's go to the second portfolio here, where we use still the same building blocks, obviously, but now rather than giving everything to one building block, which is absolutely non-diversified, we just split the weights across the 3 building blocks. So let's run this. And here we are again computing the diversification score, and we will see that 3.33. So as I said, it's on the scale up to 5, 5 being the max diversification, let's call it. So here we are pretty good compared to what we used to have, which was negative 166. So we have improved, higher score is better. So we have improved the diversification just by allocating to all building blocks rather than to only one building block. So this is just a quick illustration to help you understand what we mean by diversification. If you just use one building block, you're not going to be falling within the requirements of this competition, which is you need to use these building blocks to make the most of the strategies. So that's really it for diversification at this stage. Let me jump back to the presentation. So we've covered the diversification issues. Let's go to the robustness ranking. So why did we introduce the robustness ranking? And that's really in order to help you understand that the payout you submit has to be systematic. This is a key requirement because this will be replicated on live markets. So basically, your algorithm, which is the code you write, shouldn't be too tied or too linked to the input that you are using. So in this case, we're using the 3 building blocks, but you can make it flexible and you can make it robust so that it doesn't rely exactly on the structure of what it's taking. At the end of the day, the algorithmic part of the strategy is independent from the data you are feeding it. And the reason why it is important is that by having this flexibility, we can stress test the strategy with different data sets. Maybe if we have a set of synthetic data or maybe other building blocks that are correlated to this data in order to simulate some extreme behaviors and extreme conditions. We'll cover that in a few seconds. Let's check what usually people are missing about this type of robustness. Sometimes the payouts are using hard coding when they call the data, and usually this is pretty bad practice because you are turning your payout into something very specific, whilst it doesn't have to be that specific. It can stay general and still work. There is also a problem with the external variable referencing. Remember that you are working in the Alphien studio or in notebooks, and you are fully in control of what you are defining and in what you are manipulating in terms of data, in terms of variables. However, we do not have the same access to this to your particular user environment. So what you have defined in your environment is not shared with us, which means it cannot be replicated in the same way. There is a way, though, to make us aware of what you are doing. It's just by either defining the temporary variables that you need within your payout, or to pass the external variables, let's say the data, through the payout parameters. So we are going to cover all these points soon in our studio to make them a bit more concrete. But I'm not jumping back and forth because I cannot share my full screen at the moment. We have also some problem if your payout is not able to handle data discontinuity. You know, if you are using, for example, economic data or economic series to time your signals and allocate to one asset versus another, and you think that this indicator is a good proxy for a regime switch, for example, then you want to make sure that if there is a problem with this economic indicator and it's not being computed for some reason, then your payout is not going to break down. This is something that we want to test. You need to be able to generate your allocations, whatever the structure of the input series is, or if there is a change in this structure. And lastly, we also recommend that you use explicitly external packages, meaning if you are using a function from a package, you know which function it is because the package usually is loaded in your namespace. But again, that's quite linked to the second point here. We don't know that this function is the function of this package. So you may have very different behaviors in your payout if you don't tell us exactly which package to use. For example, if two functions have the same name, you're using one from a package and we don't have that package on our systems, then the behavior might be different. So you might see a result on your personal Alphien studio in your payout. You expect great results, and then you submit your strategy. We try to replicate it, but we don't have the same package, still the same function name, and we have totally different results, poor results, and then there is something happening that we don't manage to pinpoint very quickly, and that's making thing a bit too specific. So again, it's making it more robust if we can replicate it, and we know that in the future the strategy you have designed is behaving exactly the way you want it to behave. So just to illustrate that, let's jump back to Alphien Studio. Again, I'm going to switch screen. Okay, so we're back to Alphien Studio. Let's handle robustness. So here I've just put together a few examples to illustrate each case that we've just covered orally, but to make them slightly more concrete. A lot of people, they are creating payouts like this. So they define their payout. They only pass the returns, as we know is the requirement for the portfolio payout function, and then they call the data in here within the body of the payout. Well, now what you've done is you have made this payout very specific to this set of data. What do I mean by that? I mean that if for some reason you think your payout is good and you want to adapt it to take one more building block, let's say you have done that on 2 building blocks, and actually you're like, oh, I think we can add another building block. Then you have to change your whole payout. I suppose because here you're going to do some manipulation with the variable px, whereas you can make this much more flexible if you just use a parameter in the input of your payout. Now you can pass in anything you want, and you can add in one building block very easily. Whereas here you have to modify the internal definition of your package, of your payout. Sorry. Second point is using external variables. Now, I'm just simulating in this bit here what a user could do. So here they're like, okay, I am asking for the price of the building blocks for the competition. So here I'm running that. What does it mean? It means that I've just created a px variable in my namespace here. This is very specific to my namespace and to me as a user. Then within the payout, again, I'm only passing on returns, but then I am willing to compute some moving averages of prices. Now, indeed, I'm using price. Where do I take this price? I'm taking it from my user space here, from my environment which is specific to me. And then I'm applying the function MEA, so exponential moving average, to these prices. I'm also saying that I want the 50-day exponential moving average for these prices for each building block, basically. There is a slight issue with that. So if I just run this, and here I'm printing what it should do. So let's run this. Indeed, I can see that I have the moving averages as I wanted them. That's working. However, here, this is hard-coded, and this, if you submit the strategy, we don't know what px is, because inside the function, we only see this, basically. So you're using something that, to us, has no meaning. And the only reason why it has meaning is because it's defined here in your namespace. So rather than doing this very, very easily, you can refactor. It's a matter of just putting things at the right place, basically. You can put exactly the same line, this line 59. You can pass it on here as a parameter. And then also you can change this hard-coded value here with a non-hard-coded value, which becomes a parameter of your payout. Now you have something way more robust. You can run the robust payout and see that it is exactly the same results as it used to be. It's not much code. The code change is just refactoring, so I don't have much more lines. I've just put everything that I needed to be flexible inside the function definition, basically, the signature. And here, I have also an extra flexibility to test my payout with another, I don't know, another period very quickly if I want to, if I want to go down that route. You can do it this way, so that now you have a different, or you can pass it on here. I don't know, here. Oh. So that's giving you a whole new flexibility to test your payouts and try to optimize it in a way. Here I've only defined one single period for your moving averages. So here, as I was saying, here you have gained a bit in flexibility. Now, if you want to complexify your payouts, you can push that even further. And rather than having only one value here, you can have a range of values, okay, between 50 and 100, for example, and decide to compute moving averages over this range, and then maybe take an average of all the values within that range. This is called ensembling for people that are familiar with data science, and that is generally helping on the variance metrics of your model, meaning that it's usually improving generalization. It's more robust also in a way. So we encourage you to probably push this further and use a range of values so that you can have an average of them at the end of the day. We will probably run a new webinar in the next couple of weeks to explain that in more detail and to show you how you can do that easily on the platform. But this is not for today. We'll communicate about this soon. I was referring also to a third problem, which could be that your payout is very specific to the series that it receives. However, it doesn't need to be. It's even more general if you don't use a specific series. Here, what I've done to illustrate that is to make sure that your series can, your payout can handle discontinuity in the series. I was taking the example of economic data. What if the statistical agency of some country, for some reason, cannot compute it, cannot compute the new value? Your payouts should be able to still run even if the new value is not published. So how do we test that? Well, very easily here, what I've done is I took the returns from the building blocks. Here we can see that it's 2600 roughly dates and the 3 building blocks in column. And I'm just going to discontinue that data, that return data. So here I'm excluding all the dates from row 1000 to row 1500. So here I have a new set of returns, which I can show you here on the side. Let me just get that bigger. So I can see that I have discontinued the data here. And now I can test if my payout is able to handle this new data set. Here I'm using the static payout that I've defined in part 1 about diversification. Here, this one. Come back to it, and we can see if I run the payout on this new discontinued data that I'm plotting the new payout, so the result of strat, and I'm just doing like a point plot to show that my payout was correctly able to generate points when the input was here, and then it stopped because there was no input, but still it resumed as soon as the input came back in. So that's a very general behavior that we want for your payout, is to be able to handle such cases, so that in the future, if there is any discontinuity on your strategy, the payout doesn't break down, but it is able to continue generating payout signals. In this payout here, I am just doing very easy date manipulation. So I'm just extracting the month of this series asset returns. I'm just saying, okay, give me the months of asset returns, and I'm just going to print the first 10, basically. So here, okay. Yeah. Okay, so that's the first 10 months of my payouts. Now I'm using month here, and actually I know that the month I'm using to extract the number here is the month from the library Lubridate. How do I know that? Because I have here in packages, I have loaded in my namespace Lubridate here. It's ticked, it means that it's loaded in my user space, but this is very specific to me because some other users might not have loaded this package. So if you submit your strategy with just month, then we are probably not going to use the Lubridate version. We might use a similar function that is from the base R package, and the behavior might be different. Maybe the months will be returned as string. So to make sure that the behavior is exactly the behavior that we want as person that have designed the strategy, we need to make sure that it's explicit that it is this month function from the Lubridate package, so that we are able to run this like this. And now we know that the months function is always going to be from Lubridate, but there is no single possibility to use another function which is not the correct one, and that makes your payout more robust. So this is about it for robustness. By doing all these small refactoring, so all the four cases that we have covered so far, you are going to improve your ranking in the leaderboard. And if I go back to the presentation, the leaderboard ranking is going to define the probability really of you winning the competition, because we are going to present all these metrics to our sponsor, and the sponsor then decides which strategy, which portfolio is the best one that fits their needs. Okay, so if we want to repeat again, their needs is to have an asset allocation model to allocate between different assets in order to maximize both returns and Sharpe ratio. So this is important. This is important to make sure that your rankings on those three metrics are as good as they can be. Let's go back here, and that's pretty much it. I just wanted to have a little word of conclusion. We are here to make sure that everything is clear and transparent to you, and the reason why we have put these rankings back is for you to be able to fulfill the requirements of the competition and make sure that you are you have all the chances, or the best chances, the best probability to win it. If you increase your rankings on the three metrics, then you have a highest probability of winning the competition.